Welcome back, fellow engineers. Have you ever been asked why the hot water gets colder faster when you use a faucet in your tub than if you use the shower head in your bathroom? You haven't? Well, you're either really lucky or you're single. Because my wife asks me about once a year why, and even after a decade, she still doesn't believe me when I tell her why it happened. And it all has to do with the volume flow rate. So come along and I'll show you and my wife the physics and the math behind why the faucet gets the water colder than a shower head. The first way is to know the area of your faucet exit and then having say a gallon jug container, filling that up, timing how long it will take to fill up that gallon. That will give you your gallons per time. From that, you can find out what it is per second or per minute. The second way you can find the volume flow rate is to weigh the amount of water you capture after a certain amount of time. And from knowing the density of water, you can find what the flow rate was. Now, since I do not have a known container, I am going to cheat, and you have to forgive the fan on. Needed the extra lighting. Now, I don't have a known volume container, so I am using the bathroom's trash can. Don't worry, it's clean. Okay.
Okay, can I help?
Yeah, I have a helper with me, by the way. If you can't hear. Alright, there we go. Now, of course, we have our wonderful water. Our wonderful trash can. Since I'm using the faucet, I will only go for 5 seconds. And then when we go to the shower way up there, we'll probably do 10 or 15 seconds. And from those times, we should be able to find what the flow rate is. And we'll put cold water on. And we are going to weigh. Now that we have our water, let's find the weight. Well, that's not good. Okay. Found a way. So 6 pounds, 1 ounce. Alright, round 2, and we're going to do a shower for 15 seconds. Okay, after 15 seconds, we have 5 pounds, 2.5 ounces. Now that we have the weights for the faucet and the shower head, let's put them into this Excel spreadsheet that I had created. Alright, so the faucet was 6 pounds and 1 ounce, which is about 6.0625 pounds. And we did that for 5 seconds. Shower head was 5 pounds, 2.5 ounces, which is 5 pounds point
15625, I do believe. And that's for 15 seconds. So we got a volume flow rate of 8.7 gallons per minute for the faucet, and then only a 2.47 gallons per minute for the shower head, which, if we do a ratio, let's quickly see what change is. So the faucet, as right here, as you can see, the faucet does 3.5 times the volume flow rate than the shower. Yeah, about 3 times quicker, getting colder using the faucet than the shower. Makes sense. Now, on a whim, I decided, what's the pressure? So let's use this equation right here, Bernoulli's equation. Let's throw that in the whiteboard here. All right, let's put that up there. Now, we had knowns and unknowns. So let's see. So let's create our boundary for the faucet. So we have a shower head right here. And let's go make it a boundary like right here. So this is H1. We're going to say, make this H2. So this is our datum line. So this is 0. Of course, water's flowing down that way. We're going to make an assumption that delta H is very small. So we're going to approximate that as 0. So approximately 0, because it's going to be very, very finite, which then makes these right here the height, which makes the heights pretty much go to 0 with each other. Then we are going to assume this is normal 1 atmosphere right here. And since we are looking for the pressure, the gauge pressure, not the atmospheric pressure, and we are assuming this is section 2, that this is 0. So pressure 2 is 0. Then we're assuming no velocity, because we're going to assume that this whole area is infinitely large and there's no movement, which makes this part 0, which leaves us just this equals 0, and we are looking for P1, which is right here at the exit point of the nozzle. If we go back, so right here we have our velocity in inches per second. We want it in feet per second, so we get about 0.74 feet per second, which sounds about right. So we have velocity of 1. We know the density of water, which is 62 pounds per feet cubed. So we literally go, okay, P1 equals negative 1/2 rho V1 squared. Now, you're going to get a negative answer, which you see right here. But if you notice where we put our datum line, our line is upside down. So this is 0, and we are going down, and we are making that negative, which makes this negative correct. Got our coordinate system done correctly. And then it's a matter of just solving for the negative 1/2 rho v squared, which B2 is gamma, which is the density. B12 is the velocity squared. Now, one slight thing you have to remember, especially with imperial units, is when you get your answer in this, you actually have it in pounds force, because your units end up this weird pound over feet times seconds squared, which, if you look it up, it's pounds force. To get pounds mass, or correction, to get to the pounds per square inch, you have to divide it by 144. And you can see here, even I forgot that. I had to look that up because I was scratching my head. The units weren't matching up what I thought, so I had to look. And when I saw the units matching up for the pounds force to pounds mass, or correction, pounds force to the PSI, then I knew I was good. So a side note with the units is, if you don't know how to get started, look at what the units you need. So if you're trying to find pressure or velocity or acceleration or one of those units, then start there. Start at the finish line, basically, and go backwards until you have an equation that you can use using what is given to you. A lot of times it will come into constants and given knowns, usually for your variables. So I hope you liked the video if you made it this far. I know that this was a little bit drier than normal, and I'm hoping I can get back to more of the hands-on projects in the future. Just right now, life, family is taking priority right now. So, again, if you have made it this far in the video, consider subscribing, liking the video. That helps me out. It's actually great motivation also. So, that would be awesome. Until next time, see ya.